everyone. So in this lesson, we'll continue the discussion on space curves and vector valid function. Now I'll give you an example on how to sketch vector valid functions. Okay, so as an example, now suppose we are asked to sketch the space curve represented by the vector valid function r of t equals 4 cosine ti plus 4 sine tj plus tk, where t is from 0 to 2 pi. Okay, so from the first two components, because this is your x component, this is your y component, so therefore we can rewrite. Okay, we can express x as 4 cosine theta and y as 4 sine t. And then if you can recall, the equation of the circle is defined as x squared plus y squared equals r squared. But because x is 4 cosine theta, so we can express x squared plus y squared as 4 cosine t quantity raised to the second power plus y, where y is 4 sine t raised to the second power. By squaring each of this term, we have 16 cosine squared t plus 16 sine squared t. So therefore, x squared plus y squared is equal to, because 16 is common, so you can factor this out. So we have 16 times quantity cosine squared t plus sine squared t. But in trigonometry, this is equal to 1. So therefore, x squared plus y squared equals 16, which indicates that the radius or the square of the radius is 16, so the radius is 4. Okay, so this means that the curve lies on a right circular cylinder of radius 4 units, and this is centered at the c-axis. So to locate the curve on this cylinder, you can use the third parametric equation or the third component, that c is equal to t. So in this figure, this is the cylinder. The base is in the form of a circle of radius 4 units. Okay. So from the center, because the equation is, or the equation of the cylinder is x squared plus y squared equals 16, and we know that the radius is 4 units. So from the center to any point on the circle, the distance is 4 units. So you have 1, 2, 3, 4, and then 1, 2, 3, 4 at the back of on the negative side of the x-axis. Then 4 units along the positive y. So this is 4 units. This point is also 4 units now from the center. Okay, so connecting these 4 points, we have the circle as the base of this circular cylinder. So as you can see in this figure, that as your t increases from 0 to pi, the point XYZ spirals up the cylinder to produce a helix. And this can be obtained by assigning values to t, then you solve for the x, y, and z coordinate. Because we know that your t is from 0 to 4 pi, so you can assign values for t variable from 0 to 4 pi. Like for example, if t is 0, then x is equal to 4 cosine t, where t is 0. But recall that cosine 0 is 1 times 4, so you have 4 as the x coordinate. Then for the y coordinate, this is 4 sine 0. But recall that sine 0 is 0 times 4 is 0. Recall that the parametric equation for the c variable is c is equal to t, where t is 0, so therefore c is equal to 0. So the first point obtained is the point with this coordinates, now 4, 0, 0. So from the center, you scale 4 units along the positive x-axis, then 0 for x, 0 for y. So this point is the point 400 on curve C. Okay, so to get the other points, you assign values to t. Make sure that the assigned value of t is within the specified interval, no, from 0 to 4, 5. So in this case, if the value of t is pi over 2, so your x is 4 cosine of pi over 2, but cosine of pi over 2 is 0 times 4 is 0. For the y coordinate, you multiply 4 by sine of the angle, but the angle is pi over 2, and recall that sine of pi over 2 or 90 is 1 times 4, so we have 4. Then for z equals t, where t is pi over 2, but pi over 2 is approximately 1.57. So the corresponding coordinates, if t is pi over 2, is the point with coordinates 0, 4, 1.57. So we do the same. We assign value to for t. Let's say t is pi. So x is 4 cosine pi, but cosine pi is negative 1 times 4. So we have negative 4 as the x component. For the y component, or y coordinate rather, is equal to 4 times sine of t, but t is pi, and sine of pi is 0 times 4 is 0. For the z coordinates, recall that c is equal to t, where t is pi, and pi is approximately 3.14. So the corresponding coordinates, or the corresponding point when t is equal to pi, is the point with coordinates negative 4, 0, 3.14. At t is equal to 3 pi over 2, your x is 4 cosine of 3 pi over 2, but cosine of 3 pi over 2 is 0 times 4, so x is 0. For the y coordinate, 4 sine of t, where t is 3 pi over 2, this is negative 1 times 4, so the y coordinate is negative 4. For the z coordinate, this is equal to t, where t is 3 pi over 2, and this is approximately equal to 4.71. So the corresponding point is the point with coordinates 0, negative 4, and 4.71. And lastly, at t is equal to 2 pi, your x coordinate is 4 cosine 2 pi, but cosine 2 pi is 1 times 4, so we have x equals 4. For y coordinate, 4 sine t, where t is 2 pi, but sine of 2 pi is 0 times 4 equals 0, so the y coordinate is 0. For the z coordinate, this is equal to t, but t is 2 pi, and 2 pi is approximately equal to 6.28. So the corresponding point at t is equal to 2 pi is the point with these coordinates 4, 0, 6.28. So this is the first point. When t is 0, you have 4, 0, 0. When t is equal to pi over 2 or 90 degrees, diba, from the x-axis to the y-axis, that's 90 degrees. So this indicates that you have to scale 0 for x, 4 units along y. So from the center, along the positive side of the y-axis, you scale 4 units to the right. And then after that, the z coordinate is 1.57. So you have to move upward by 1.57. So assuming that this is approximately 1.57. So this point, therefore, is the point with coordinate. This is the point with coordinates 0, 4, and 1.57. Okay? At t is equal to pi, so that's 180 degrees, no, from the positive x-axis. So meaning on the negative side of the x-axis. So from here, okay, since the x-coordinate is negative 4, so you scale 4 units along the negative side of the x-axis. So this is negative 4. Then 0 for y. And then for the z coordinates, that's 3.1416. So from here, assuming that this is 3 units upward plus 0.14, so this point is the point with coordinates negative 4, 0, and then 3.14 pala, 3.14, yan. Okay, so this point is the point with coordinates negative 4, 0, 3.14. At 3 pi over 2, so from the positive x-axis, you scale what? 3 pi over 2 degrees. So this is 90, 180, then this is 270 or 3 pi over 2. So at t is equal to 3 pi over 2, the x-coordinate is 0, the y-coordinate is negative 4. Meaning from the center, you scale 4 units along the negative side of the y-axis. And then since the c-coordinate is 4.71, so you scale 4 and then 71 units upward along the direction of the c-axis. So from here, 4 units upward plus 0.71. So this point, therefore, is the point with coordinates 0, negative 4, and 4.71. Okay, that point. Okay? And then at t is equal to 2 pi, so this is where this is one complete rotation, no, from the positive x-axis. So this is 90, 180 to 270, and then 360 or 2 pi. So at t is equal to 2 pi, your x-coordinate is 4 units. So scale 4 units along the positive side of x. 0 for y, but for the c-coordinate, this is 6.28. So you scale 6.28 units upward along the direction of the c-axis. So from here to here, this is 6.28 units distance. So therefore, this point has coordinates 4, 0, 6.28. Okay, so you do this for the rest of the angle after 2 pi. Next is 2 pi plus pi over 2. So this is what? 1, 2, 3, 4, 5. 5 pi over 2. Okay, at 5 pi over 2, get the x-coordinate, the y-coordinate, and the c-coordinate to get the coordinate of this point. But obviously, the x-coordinate is 0. The y-coordinate is 4 units. So you have to find the value of c, where c is t, where t is 5 pi over 2. So what is 5 pi over 2? Using your calculator. This is 7.85. So this is 0, 4, and then 7.85 for the c coordinate. So you do the same procedure or steps to find the coordinate of this point. Okay, and the other point na from up to 4 pi. So in summary, the vector value function can be expressed in terms of ij form or in vector form. In ij form, for two-dimensional space, the vector value function r of t is f of ti plus g of tj. And in three-dimensional space, the vector value function r of t is defined as f of ti plus g of tj plus h of tk. So these are the components. You have the f, g, and h as the real valid function of the parameter t. Okay, so as I said, the second form of the vector valid function are in vector form. You can write r of t as in terms of component form, or in vector form as f of t comma g of t, where the first vector valued function f of t is the x component and g of t is the y component in two-dimensional space. R of t in three-dimensional space is defined in vector form as f of t, g of t, h of t, where f of t is the x component, g of t as the y component, and h of t as the z component. Okay, the domain of the vector valued function is the intersection of the domains of its components.